In this video, we're going to look at the concept behind conditional probability and at least probability for your maths exam. After going through this video, you will understand the concept behind conditional probability and questions of at least probability for maths exam. So you sure you stay at the very end of the video. Alright, so having known this, let's go into the details of the video. Now let's begin with conditional probability. Let me get a question that will help us to explain conditional probability. Alright, so let me get a question. Okay guys, now let's look at this question. The question says Alia either watches TV or reads before bed. The probability she watches TV is 0.3. If she reads, the probability she is tired the next day is 0.8. What is the probability that Alia reads and isn't tired the next day? Alright, now let's recall that conditional probability is used when you have dependent events. Alright, where one event affects what the other. Okay, that's the other event. Now, for this question, let's look at the formula we're going to apply to deal with problems involving conditional probability. So basically, the rule here is that the probability of events, let's say A and B, both happening, is equal to the probability of event A happening multiplied by the probability of event B happening, given that event A happens. So basically, mathematically, it can be expressed as the probability of event A and B both happening. That's probability of events A and B both happening is equal to the probability of event A happening. Alright, probability of event A happening multiplied by the probability of event B happening. Probability of event B happening, given that event A happens. Okay, so given that event A happens, given event A. Okay, so basically this is how you can express it mathematically. Alright, so with this formula, let's apply it to solve this question we have above. To begin to solve this question, we have to label our event A and B. Since in this question we asked to find the probability that Alia reads and isn't tired the next day. Okay, we are going to label the probability that she reads and isn't tired as our events A and B respectively. Okay, so we are going to call or label she reads as our event A. Okay, probability she reads, okay, will be our equals to our probability of event A, and the probability that she isn't tired given she reads. Okay, will that be the probability of event B happening? Okay, given that A happens. Okay, B given A. Alright, so basically for this one, that the probability of event A happening, that's she reads, will be, we are going to use the information in this question to work out the probabilities we need for this formula we have here. Okay, so the probability of event A that she reads will not be, okay, since in this question, the question says Alia either watches TV or read before bed. The probability she watches TV is 0.3. Remember, in this question, we have or here, that's TV or she reads, and or rule signifies addition. So this is going to give us, we have that of TV to be 0.3 if she watches TV, so it's going to give us 0.3 y plus she reads. We're looking for event A. Let's probability of event A, okay, will be equals to 1. Alright, we know that probabilities add up to 1. So either the events will happen or it will not happen. So one outcome has to emerge. Probabilities add up to 1. Alright, so having known this, when 0.3 crosses over the equality sign, it turns negative. So the probability of event A happening here and now, that earlier is will not be 1 minus 0.3. So when you punch it in the calculator, you're going to have it to be 0.7. Okay, now for the probability that she isn't tired, given she reads, all right, the same thing here. The probability that she is tired the next day is 0.8 if she reads. Now what we're going to do is we're going to equate the probability that she isn't tired given she reads, that's this probability, to 1. We're going to have it to be probability that she isn't tired given that she reads, this is G, okay, plus the probability she reads and she is tired the next day, which is 0.8 equals of 1. Alright, so when this 0.8 crosses over the equality sign, our probability that she isn't tired given she reads will now be 1 minus 0.8. Okay, so when you punch it on the calculator, you're going to have it to be 0.2. Okay, now that we have these values, let's go ahead and plug them in this formula we have here and we get the solution. So let me wipe the middle. Okay, now to now apply the values we have gotten to this formula above. Remember that the probability that earlier reads we got, we have it to be probability of event A, that she reads, we have got it to be 0.7. So when we plug everything in this formula here, we're going to have 0.7 times the probability she isn't tired the next day given she reads, okay, which we got to be 0.2. So when we punch everything together, we're going to have it to be 0.14. Alright, so that will be the answer to this question. Okay, so this is basically how you can deal with conditional probability problems. Alright, now having gotten these concepts, let's wipe this and look at how to deal with questions involving at least probability. Very important concept. Before we call this a class, let's wipe this. Okay guys, now let's look at this typical question for at least probability. It says I roll 3 fair-sided dice. Find the probability that I roll at least 1 6. Okay, now take note of this. Pay attention guys, that when a question asks for at least a certain number of things happening, it's usually easier to work out. All right, all you have to do basically is to subtract the probability of less than that number of things happening from 1. All right, so the formula we're going to apply will be to subtract the probability of less than that number of things happening. Okay, this is basically the formula we're going to apply. We're subtracting this probability from 1. All right, now let's go ahead and solve this question. Firstly, we need to rewrite this as 1 minus the probability. Okay, so it's going to be mathematically from this question, this can be expressed as probability of at least 1 6, which is the same thing as 1 minus probability less than 1 6, which is the same thing as 1 minus probability of no 6. Okay, Now that we have expressed this mathematically, the next thing will be to work out probability of no 6. Alright, now we can use a tree diagram to work this out. So the tree diagram for this at least probability will look like this. Since we are going to subtract the probability of no 6 from 1, because when I go three-sided dice, the probability that one will at least 1/6 will be, okay, we need to get the probability of no 6. All right, let's say this is a tree. Let me draw it here. This is a tree diagram. Let's say this is 6. All right, this is not a 6. All right, this is another tree diagram. This is 6, not a 6. This is another tree diagram. This is 6. Okay, this is not a 6. Okay, now for not a 6, we're going to have it to be 5/6. All right, for not a 6, we're going to have it in this second tree. We're going to have it to be also 5/6. This one will also be 5. This 3/6. Okay, now to now get the probability of no 6, it will be to multiply the 3 no 6 we got, which will be 5/6 times 5/6 times 5/6. Alright, so when you punch into the calculator, you are going to have it to be 125/216. Alright, now our final result will be to subtract this value from 1. Alright, it will be 1 minus 125/216. So when you punch it into the calculator, you're going to have it to be 91/216, and that will be the probability that I will at least 1/6. All right, so basically this is how you can deal with at least problems of probability. Make use of a tree diagram to do it, just as I have illustrated here. The main idea is to subtract the probability of less than that number of things happening from 1. Okay, so this is basically how you can deal with problems involving conditional probability and at least question probability. Hope there's something interesting from this video. Let's call it a class here. No part this question. The main idea is for you to understand what's happening. Okay, now if you are new to the channel, ensure you check the description of this video below now for a link to our Telegram channel. Click on it and join the Telegram channel for instant notification. Also ensure you are subscribed to this channel by hitting the subscribe button now for more videos like this. Like, share, and comment on this video. Tell me how you feel from what you have learned from this class. If you seem to have any specific question to ask regarding this conditional probability, feel free to leave your question at the comment section below, and I'll ensure to give you a response. Okay, so that's it for this video. Now click on the end screen above and I'll see you in the next video. Thanks for watching.